The I-beam or T-beam are commonly used in building various types of structures. When doing a stress or deflection analysis for a beam, the location of the centroid is very important. After this lesson, we will be able to determine the location of the centroid for a given beam shape. The compressor is assembled with many individual components. In order to design the ground support structures, the reaction at blocks A and B have to be found. To do this easily, it is important to determine the location of the compressor's center of gravity. If we know the weight and center of gravity of individual components, we need a simple way to determine the location of the center of gravity of the assembled unit. Consider a composite body which consists of a series of particles or bodies. The net or the resultant weight is given by this equation. Summing the moments about the y-axis, we get this relation where x1 represents x coordinates of w1, etc. Similarly, we can sum moments about the x and z axis to find the coordinates of g. It may be noticed that summation is used when number of particles are finite, while integration, as discussed in the previous video, is used when dealing with infinite number of particles. By replacing the w with m in these equations, the coordinates of the center of mass can be found. Many industrial objects can be considered as composite bodies made up of series of connected simple shape parts or holes like a rectangle, triangle, and semicircle. Knowing the location of the centroid C or center of gravity of the simple shape parts, we can easily determine the location of the C or G for the more complex composite body. This can be done by considering each part is a particle. This is a simple, effective, and practical method of determining the location of the centroid or center of gravity of a complex part, structure, or machine. Here are the steps for analysis. Divide the body into pieces that are non-shapes. Holes are considered as pieces with negative weight or size. Make a table with the first column for segment number, the second column for weight, mass, or size depending on the problem, the next set of columns for the moment, arms, and finally several columns for recording result of simple intermediate calculation. Fix the coordinate axis, determine the coordinates of the center of gravity or centroid of each piece, and then fill in the table. Sum the columns to get x, y, and z using this formula. This approach will become more clear by doing exercise. As given in this example, a composite shape, we need to find centroid of this part. Following the analysis steps, this body can be divided into the following pieces: rectangle, triangle, quarter circle, semicircle. Note the negative sign on the hole. Now make up and fill the table using part A, B, C, and D. So in this table, the first column, which has 4 different segments: rectangle, triangle, quarter circle, semicircle. The second column shows area for the 4 different segments. And the third column is the x tilde, which is the location of centroid of the individual shapes in the x direction. And the fourth column represents y tilde, which is the centroidal location in the y direction of each individual shape. And the last 2 columns shows the product of x tilde A and y tilde A. Now use the table data results and the formulas to find the coordinates of the centroid. And using the summation equations, x bar becomes 2.73 inches and y bar becomes 1.42 inches for the composite shape. Thanks for watching.